Okay guys, what we're going to look at now is what we call interpolation and extrapolation. And again, this is a topic that the Wiskunde R students in particular will do in more detail next year. Alright, now, firstly I want to look at these words, interpolation and extrapolation. Now, inter and extra. Okay, that's what's changing in these two words. Now, we need to firstly think about what that means. Inter means inside. Extra means outside. Okay, and what this means is we are going to look at data that is in between things and outside of things. Okay, so we're going to look at extending a range to make an estimate, and we're going to look at estimating between two values. All right, now what you can see over here on the right is that I have pasted a population graph. This is actually a population table. This is actually for Rotterdam. Okay, so this is Rotterdam's historical population. Okay, these are the dates that they've done a census or whatever, and this is a list of the populations at these times. Okay, starting in 1398 and getting all the way up to 2020. So now what you can see, if you look at the change per annum, that's what the PA means every year, that it's not always consistent. Okay, so sometimes it's +1, then it goes -1.58, +0.79, etc. This changes throughout the table. It's not always consistent. What that means is that this is not a linear graph. This is not a linear relationship. This is not an exponential relationship. This is just a relationship that changes. Okay, so if we were to graph this, we would get something that looks a little bit like this. Okay, we'll get something like this. All right, now with interpolation and extrapolation, we know, you can see in this table that we've only been given certain data points. Okay, so we've been given for example 1984, but then the next data is not until 2005. Okay, that's 20 years later. All right, so our next data wasn't for 20 years. Okay, what that means is in between 1984 and 2005, let's say we want to know the population in 1995, we need a way of estimating that. Now with interpolation and extrapolation, it will always be an estimate. Okay, these are not exact because we don't actually know what happens in between the data points that we do know. Okay, now interpolation means that we are looking at values inside the table. Okay, so we're looking at values in between the values that we know. Okay, extrapolation means that we either go outside the graph on the high end or at the low end. Okay, so for example, we could estimate the population, what it will be in 2030. Okay, or we could estimate what it was in 1350. All right, now again, these are always estimates because we don't actually know what happens to the data in between data points and outside of it. Okay, so with interpolation, that's the one we're going to start with. We use the values that we know to calculate one we don't know. So I said to you before, let's see what happened in 1990. Let's estimate the population in 1990. Okay, so let's do that. Let's start with 1990. So if we want to estimate the population in 1990. Okay, that's what we're going to do first. Now you can see that 1990 is in between 1984 and 2005. So we're going to use these two data points. Now the really important thing with interpolation is that you always use the two data points that are either side of it. Okay, so we assume that it's a direct straight line in between those 2 points. Even though it probably isn't, we are going to assume it is, but you must always use the closest 2 points to the one you are working with. So if we want to know what happens in 1975, we cannot use these two data points to find that out. We would need to do all these calculations again. So for 1990, all right, we have firstly 1984, so we need to look at our 2 points. We have 1984 is 555,000. Okay, and 2005 is 596,407. Okay, so these are our two data points. All right, the first thing we want to do is we want to look at how many years this has changed by. So from 1984 to 2005, that is 21 years. So we have 21 years. I've not left myself enough space here to write it. So I'm going to just quickly move it over. Okay, so we have had a change here of plus 21 years. Okay, now on the other side, if we look at how many people it changed by, we have 596,407 minus 555,000. Okay, which is plus 41,407. Okay, so this is what we have. We know that in 21 years, so in 21 years, the population increased by 41,407 people. Okay, now what we can do then is we can look at what that change would be each year. So this means a change, of how many people per year. Okay, and we're going to calculate that. So if we know it's 41,000 people in 21 years, then all we do is we take that number and divide it by 21. Okay, so we have a change of 1,971.76. We're going to keep that decimal for now, but at the end we obviously have to round it, people per year. So this is the change per year. Now we wanted to know 1990. So from 1984 up to 1990, and again I've put it way too far to the left, so this is making it difficult. From 1984 to 1990, that is a change of 6 years. So we have plus 6 years. Okay. Now in 1984, again, we had 555,000. And in 1990, that's the one that we don't know. Okay, but to calculate it, we have plus this wonderful number that we just came up with. So 1971.76 times how many years it was, because this was the change per year. We know we had 6 years, so it's times 6. So if we times 6 by that original lovely number, we get 11th. Oh, that's not right. Oh, yes, that's fine. So we get a change of in 6 years, the population increased by approximately, so remember this is an estimate, 11,831, okay, because we're rounding up there. Okay, now this is what happened in 6 years. So now to work out our final answer, therefore, in 1990, the population estimate is 555,000 plus 11,831, which gives us 566,831 people. Okay, so this is what we are estimating the population would have been in 1990. Okay, this is interpolation because this was inside on the table. And as I said, it's really important that you use the two values either side. So if we wanted to know, for example, 1800, we wanted to know the population in 1800, we must use these two values to work that out. Okay, now for extrapolation, as I said to you before, we can estimate the population in the future or way back in the past before the table started. Now we'll do 2030. Okay, so what is the population? What is the estimate population in 2030? Okay, let's have a look. So when you're extrapolating, you must use the data closest to what you're looking at. So in this case, we must use these two on the end here. Okay, so we must use these last two data points. Okay, so we have in 2014, whoops, change my pen back. 2014, we had 624,799. And in 2020, we have, I have to do this a little bit quick because I'm running out of time on the video, 651,446. Okay, so this was a change, and we want to know 2030. This was a change of plus 6 years. And on the other side, we had a change of 651,446 minus 624,799, which is plus 26,647. Okay, this is the change that we had in 6 years. So that's what it changed by in 6 years. All right, so this gives us, divided by 6, a change of, so the change is plus 4,441 people per year. Okay, now if we're going from 2020 to 2030, okay, our change here is plus 10 years, all right, and our change on the other side is therefore going to be plus 4,441 times 10, okay, and this gives us a value of, so plus 651,446, this gives us a value of 695,857 people. And you may have had 856 because I also included the rounding from the previous answer. Okay, so I didn't round before I did this. So this would give us an estimated population. So the estimated population in 2030 is 695,857. Okay, now the really important thing that you get from this is that you must use the data closest to what you're working with. So with extrapolation, we assume that this last trend continues on in the same trend forever. Okay, so we assume that it continues with the same trend that it has been. Okay, thank you.